Let us see about input-output management. There are three types of input-output devices. First one is human readable. These are the input-output devices where the user directly communicate to the computers. For example, keyboard, mouse, printers, etc. And machine readable input-output devices are those where we communicate to the computers through some other electronic equipments like sensors or any USBs, etc. And the final type is communication. These are the input output devices used for remote communications, that is long distance communications like modem, digital line drivers, etc. So what is the difference among all these three types of devices? These are the parameters shown in the figure are the differences among the input output devices. Every input output device vary in their data transfer rate, that is the speed of transferring the data and receiving the data may differ. Every input output device might be used for different applications, and the complexity of control also differs with every input output devices. For example, keyboard, mouse may be completely controlled by a user, but the communication devices like modem, USBs, they cannot be completely controlled by the user. They follow the instructions from operating system. Some devices transfer the data in serial way, some in parallel communication. Some will transfer the data bit by bit, some will transfer byte by byte, and some as stream of data. And next, the data representation differs between the input output devices. Some input output devices uses ASCII coding, some will use EBCDIC coding, and every input output device follows different data encoding schemes. The final parameter which gives the difference between the input output devices are error conditions. Every input output hardware behaves in a different way when an unusual event occurs. Some will send the report to OS, which will be tried to solve by OS itself. Some will report to the user so that manual interruption may be needed. Like that, every device handles the error condition in different way. This diagram shows the data rate or the transfer of data or the speed of receiving the data of all the input output devices, such that keyboard is having a low data rate, and when you go up, some input output devices will have gigabit, Ethernet, etc. For example, modems, those will have high data rates. There are three types of techniques available to perform any input output operation. First one is programmed input output. In programmed input output, the CPU frequently checks whether any input output command is raised on behalf of a process, and if any input output command is raised, then it executes the input output operation, and then it continues the process in a normal way. If there are no input output command raised, then it proceeds the process as usual. The second type is interrupt driven input output. In this case, the CPU need not to manually check for any input output command raised by the process. Instead, an interrupt is raised by the process through operating system so that the processor executes the input output command of the process, and once when the data transfer has started, then the OS submits another process for execution so that the current process is put in the blocked state, and the next process will be in execution. The third type is direct memory access. This is a method to exchange the data between the input output module and the main memory, where this technique reduces the intervention of CPU for every input output data transfer. This diagram shows the same functionality what we have discussed in the previous slide. If programmed input output is used, then no need of interrupt because directly it is handled by processor. If it is interrupt driven input output module, then an interrupt has to be handled by the processor. And if it is a direct memory access, the interrupt may be handled directly by the DMA, and the intervention of CPU is reduced over here. These are the three types of configurations of DMA. In figure A, a common bus is used for data transfer between all the devices in a computer. So, when an input-output device raises an input-output command request for data transfer, then the processor has to do the address calculation so that the common bus is utilized by all the devices in the system. So the processor is interrupted frequently for every input output devices. The processor calculates the address and hands over the details to DMA so that the DMA takes care of input output transfer of the data of a process. But anyhow, since common communication bus is used, processor is interrupted in between by the usage of input output devices to transfer the data. But this problem was reduced in figure B, so that once when DMA gets all the address details of the data to be transferred, then every input output device need not to access the common system bus, so that DMA handles whenever the data transfer has to be taken care. So the interruption of CPU for access of system bus is reduced here. In figure C, a separate input output bus is provided so that the processor is not at all disturbed in between for its execution, so that the DMA completely takes care of data transfer between all the input output devices.